Today we'll be discussing the issue of ToolBox, and this is actually something we've had inside InventorCAM for a couple of years now. However, we've also noticed that not too many people know about it and not too many people use it. And so we decided we should do a webinar on this issue. Now, what exactly is ToolBox? One more thing, important. Before I continue, in fact, just a quick reminder, when we have the webinars, at the end, I allow time for questions. To ask a question, let's get this thing to work. Hold on a second, please. Yes. To ask the question, all you have to do is where it says raise hand, click on raise hand. In the questions box, write down your question that you may have. When you finish the question, when you finish writing down the question, click on send. And at the end of the webinar, I'll go through all the questions that you may have over here. Again, all you have to do is click on raise hand, write your question in the questions area, and then when you finish writing the questions, all you have to do is click on send. And at the end, I'll go through the questions and answer them to the best of my abilities. Okay. So as I said, we'll be talking about the option of ToolBox that we have inside InventorCAM itself. Now, what exactly is ToolBox? ToolBox is it's actually like a canned program. Just like you have on machines, you have canned programs, let's say for drilling or sometimes pockets even, where all you do is just give it a shape and the machine itself gives out the exact moves. The same thing we have inside the ToolBox itself. You decide, you pick the specific type of operations you want, and it'll automatically give you the exact tool path that you need for that particular operation. And if you take a look at the part itself that I have over here, you'll note I have a whole bunch of different types of shapes, and I want to go through a number of them to show you exactly how convenient ToolBox sometimes can be for you when you want to program something relatively quickly. Okay, I've already done the operations themselves, and I'll go through the operations one at a time. Now, inside the operation, first of all, where's it located? Operation, add milling operation, and we have here ToolBox cycle. Now let me open up the first operation, and we'll take a little closer look at the windows themselves. Now you'll note that that in the ToolBox cycle operations, we have our technology area. Now you'll note the rest of the windows actually look very similar to all of our operations. If we take a look though at the technology, and I click on this area over here, you'll see a list of all the different types of operations that we have inside the ToolBox itself. We have one called spiral open slot. We have one here called closed slot. We have here one for broaching, in fact. We have here for O-rings. We have all different types of operations that are constantly done on that we come by sometimes on a daily basis. So we've made it actually a canned program, a canned movements for these type of operations. And by doing so, you're actually going to be cutting down on your programming time as well. Now, the first one I'd like to do, we just close this one that I have over here. I'll take the first operation that I created over here. And what I'd like to do is work on this slot as shown over here. Now the way I'm going to work on it is what we call a spiral open slot. I took the very first operation over here, and if we take a look at the picture, you can see the exact tool path that we're going to have over here. In this picture on the right hand side, you can see that it shows you the actual entities that you need to pick for your geometry. Now, note it does not have any arrows or anything like that. It just shows two entities picked. The direction does not matter. Okay? If I were to take a look at the geometry itself, you'll see that I have these two lines picked as my chains. My first one and my second one. The tool in this particular case will be a 10mm end mill, and my levels will be going down to that floor over there, which is at 10mm. Now let's go into our technology field, and all we have in our technology field is, first of all, the step down and the minimum and maximum cutting angle that we want inside our toolpath itself, our engagement angle. If we take a look at the picture, you know, as it goes through the part, we have an engagement angle that it has to deal with. So, and that's the only thing you give it. You don't tell it to step in. You just tell it what's the engagement angle that you need. If you want, you can also do a rough cut with an offset, and then do a finished cut as well. Let's just take a quick look at the simulation itself. You'll note, now take a look from the top view itself, and let me just zoom into this area. You'll see the tool path going around. I'll even show the tool so you can see exactly what's going on here. You see the tool goes in. Now, as it repositions itself, it picks itself up about 0.2 millimeters off the floor and goes to here, goes to the other side in a rapid movement. Very similar to the way iMachining works. And as you see, it goes across that entire slot. All I had to do in this operation was to pick my two chains, and then let the rest do this out. I pick my geometry, my tools, and my levels. The technology, the default value is between 40 and 60, but if you want, you can change it. And if you want, you can have a rough off cut and a finish as well. Now let me go to my next operation that we have in ToolBox. I'll open that up. And this is spiral open slot wide. Very similar to what we did before, but this time this is a wide slot. So the way we did this was we had the spiral open. We open up the middle with these spiral cuts, and then the walls themselves we finish off with parallel cuts to the edge itself. Again, the geometry as shown over here are these two edges over here, each one of them being a separate chain. And my tool would be the same end mill, level, the exact same thing. In my technology, I have the exact same option I had before. But this time I also have control of my moat width. In other words, I'm basically creating a moat over here through the part itself. I can control how wide of a moat I want. Again, we have our retract height. As it retracts off the floor of the part, how high to go up from the floor of the part. And then when we finish our cuts over here, our moat as shown over here, the spiral cuts that we had in here, we have our parallel cuts. How much do we want to step over each time? Now we can do that also one way or zigzag back and forth. And again, we can leave an offset and do a finish as well. Taking a look at the operation itself, let me again show you with the tool itself. And I'll zoom into this area. You can see the tool is going in. Let me do this relatively slow so we can run actually ahead. You'll note it's going down the middle. And then it'll actually finish off the sides itself, as shown over here. Okay? These are basically, like I said, canned operations. Now, I'm not going to go through every single one of them, but I want to show some of the major ones. And I'll continue on to the very next one, where we have a slot like this, a wide open slot where it's closed at one end. Opening up the operation. You can see the picture that we have here. It's going to spiral slot through here and then clear off the middle. You can see by our geometry that all we have to do is pick this area here. We do not have to close this. This is done automatically. The direction, however, is important, that you put the proper direction inside the geometry. If we take a look at the geometry itself, you can see that this here is the geometry as shown over here. Next, of course, we have our end mill, same one we had before, the same levels. In our technology, it's very similar to that we had before, with our minimum cutting angle and maximum cutting angle, and our moat width. In essence, it really has all of the same information that we needed for the previous operation, except now it knows that this is closed at one end. So the tool path will actually be, and I'll take away the show tool now, through the middle of the part, and then clearing off the edges as shown over here. Okay. Now, our next operation is a very common case where we have a slot that we want to mill out. Now, we have two of these type of cases, but the first one I'd like to show you is this one here, where the slot is relatively wide. And if I were to open up the operation, we have what we called additional zigzag slot, as shown over here. If we take a look at the diagram that we have on our right hand, on our left hand side on the bottom, excuse me, you can see this is the actual tool path that's going to happen. It's going to go down zigzag up until its first step down, work its way across, and then go down again and work its way back. When it finishes that, then it'll work towards the sides parallel to the geometry itself. The direction of the geometry of the chain that we create over here does not make a difference. Now in this particular case, again, I'll use the same end mill, a 2mm end mill, going down 10 millimeters. This time, just to show you how this works, I'm going to have a step down of every 5 millimeters with a ramping width of 20. In other words, what's the actual width of the ramp itself? Again, here we have a wall offset, floor offset, and of course the parallel cut step over, how much of a step over you want every single time. Let's take a quick look at the geometry, at the simulation. And I'll zoom in over here. We'll actually do this one step at a time. You can see that my tool zigzags in, goes across to the other side, clearing off this whole area, and then continues zigzagging until it gets to the bottom of the part. When it finishes that, it'll start working its way around, working parallel to the floors. And this is again done automatically just by picking that particular option, and the program takes care of the rest as far as how I want it to work. Now, if I were to go into my next operation, it's really a simple slot. Now, many times what people want to do when they work on a simple slot like this is they want to go across this wall over here. Then without going up, they wanted to go just a little past the part itself to go to the other side and then continue by going back across. Now, if you use the regular profile operations, when you pick these, in order to keep it down like that the way you want, what you normally would do is you'd create a sketch along here, which would make a sketch that goes from here, another line going here, and one back. And this line would be further back in here in order to keep the tool exactly on the tool path that you want. Now, of course, this takes time because you have to create that sketch itself. So what we've done here is we actually created an operation that all you have to do is pick these two lines over here. You do not have to make any kind of extended line at the end over here, and it'll automatically do the exact motion that I just talked about. If I were to open up the operation, you can see we call it simple slot. And you can see from the tool path that we have down here, that's what's going to happen. It's going to go across. This is the center of the tool. Is going to go across, back to the other side, and then back down. Taking a look at the geometry itself, you can see we have the first and second geometry over there, second chain. The tool I'll be using the same end mill, and in my technology field, all I have is step down for the finish, then and offset for the floor itself, offset from the wall and from the floor. Okay, taking a look at the simulation itself, looking from on top, and we'll zoom into this area over here. You'll see, let me just show the tool. The tool will go in. Notice not exactly at the very end. Go out, and then just do a finish cut towards the wall itself. Very simple operation without creating any other sketches. Now, our next operation actually is something that's looks very, very simple, and it's actually just a simple slot over here. And the way what we're going to do in this particular case is the person would want to work in this case where the tool is the exact diameter of the slot itself. So all he has to do is just go down the center, into the go across, and as he's going across, it'll actually go down the Z as well, and go back and forth in zigzag motion up until it gets to the bottom. Now, if we take a look at the operation itself, you can, sorry, wrong operation. Here we go. There we go. You can see that this is going to be the tool pass down the middle. Our geometry, though, is you don't have to create a line in the middle. All you have to do is just take the slot itself. Okay? Of course, we have our tool, which is the same width as that particular slot. We have our levels, and we have our step down. Okay? How much we want to go down each time. Let's take a look at the simulation in this particular case. And what you'll see is as follows. Let me just get rid of the show tool. You see the tool goes down in a zigzag fashion along the part itself until it gets to the very bottom. Just run it now until the very end. And what we see now is that it did this up until the bottom, and at the bottom it just does one pass on the entire floor to clean off the floor itself. So I did not have to create a sketch in the middle. It automatically knows exactly where the middle of this is and goes down the middle of that slot. Something that's used pretty often also over here as well. Now, next, I'd like to show you is we have an open slot. Now, this open slot that we have over here, it's basically parallel going across, but note that it doesn't have to be like a regular straight slot or anything. It could be something like what you see over here. If I were to open up the operation, what you're going to see is, first of all, our geometry. The direction is important, but you don't have to close it. And what's going to happen is the tool is going to go in the center, then go off to the side, work around, and then come out, wasting as little time as possible on the part itself. Again, in my technology, there's very little for us to do. We have our step down, we have our offsets, and that's it. Let's take a look at the simulation itself, looking from on top. In this area over here, the tool goes in, goes out, and back out of the part itself. Okay, now let's go into the next operation. This operation is, let me just explain the case itself that we have over here. Sometimes you want to go on a floor, on a part all the way down to the bottom. However, you do not want to cut off the material at the bottom. You want to maybe break it off later on. So sometimes you need to build little bridges over here. Now, what we've actually done in the program is we've eliminated the need to build the bridges. It'll do that automatically. If I were to open up the operation, we have it's called 4-nub cycle, creating nubs around the part as it's milling the floor over there, the walls over there. The geometry in this particular case is just the wall. That's it. That's my entire geometry. However, okay, we have our tool, a 10 millimeter end mill. Our levels is down to the very floor over here. And in our technology is where the brain sits over here. What we have is as follows. First of all, bridges. To create them automatically or manually create them. By automatically creating them, it'll pick the points automatically where the bridges are made. Manually, you can pick the mount and the point and the places where you're going to have those bridges. Now, number of bridges in this particular case is 5 millimeters, as shown over here. The number of bridges is 4 bridges. The bridge width is going to be 5 millimeters, and the thickness, in other words, from the floor up, how much you want to actually go up from the floor, is going to be 0.5 millimeters. Taking a look at the simulation, you'll note that the tool, hold on, let me do this slowly, one step at a time. You'll see that the tool goes down up until the floor itself. In this particular case, 9.5 millimeters. And then it'll start completing down to there, working only in that area. I did not have to draw this. I just drew this just to illustrate exactly where it's working. Okay? Same thing over here, jumping over that area. And this is all thanks to this option over here of building those bridges automatically. Okay. Next. Excuse me. I want to talk actually now about the next operation called corners. Now, normally when you do an operation over here, say using a profile operation, you choose this as your geometry and give it a clear offset. Now, with a clear offset, it gives you a lot of wasted moves because it goes in areas where it does not really have to work, because it goes according to the length of that line. If I were to open up the operation itself, you'll see as follows. We have the geometry called, the option called simple corner as shown over here. We have the corner itself. Note the direction is important, but all you have to do is just pick that one entity. It'll automatically recognize this corner according to the direction that we're working on. The tools, again, the 10 millimeter end mill, levels as shown over here. In our technology, we have our step down and we have our step over. Note we don't have a clear offset because this is automatically done by in the background. It extends these two edges to know exactly where the a part actually ends. If I were to run my simulation, you'll see, and let me run it from the top. Excellent. You'll see that the toolpath goes across the part itself, but note this line is the only line that's the exact length that we need over there. These lines, since it has less of an area to clear, are shorter, and since it wasn't a clear offset, but rather a canned option, the clear offset would have actually given you a line that goes, this line would have been starting from here, going up until here. Using this option, it automatically trims it and works only where it needs to work over here. Now, I want to jump ahead to two more options over here. I want to jump ahead now to this and this option over here. This option over here is what we call a ruled surface. If I were to open up the ruled surface itself, you'll see that we have our geometry that needs to be picked, and this is the tool path that we're actually going to get, where it's actually going from one size to the smaller side, from the larger size towards the smaller size itself. Our tools, same thing as before, our levels, and our technology. In our technology, we have our step over, how much do we want it to step over at the wider side, and whether we want to work across or along. I'm going to leave it at along. Toolpath linking either one way or zigzag. We do have a wall offset as well as the finish. Taking a look at the simulation itself. Put this in the top view, and I'll run this slow. You'll see the tool goes in and back and forth on the part until it finishes it. The 3 millimeter step over is what's on this side itself. Okay. Now these are in the program itself. Anyone can go ahead and start using it. I just want to let you know that we have these options. Now one more option I would like to show you is this one over here called Oring. This is a typical operation that happens in many machine shops, where you have to put an O-ring in the inside on the part itself for whatever reason. And the way you would love to work on it is to first go down dead center, maybe even spiral around the dead center, and then clear off the walls. So if I were to open up the operation itself, called O-ring, as shown over here. Our geometry, no, it does not make a difference how you pick it. So I have my geometry over here and over here. Again, my tools in this particular case are 4 millimeter end mill. And in my technology field, we have our step down, how much to step down each time, approach angle if needed, wall offset, and so on and so forth. Now you'll note that the O-ring that we have over here, the way you would normally do it in the middle, for the middle pass, you'd actually create a geometry, a chain geometry, which sits dead in the middle. However, over here you do not have to do that anymore. You do not have to create a chain in the middle of that circle over there. All you have to do is use what's there already, the two geometries, and it'll know to go exactly in between the two of them. Okay? If I were to look at now at my simulation, you'll see, and actually let me just do this one step at a time. You'll see that the tool, here we go. You'll see that the tool goes down, and it goes down actually with a helical movement. No, not going up once, but keep on going helical to the bottom. And this is through the dead center of the tool, as shown over here. Everything's dead center. Continuing on now, we start moving off to the sides to complete this entire operation. Okay. Now, I can go on and on with these options over here, but I'm not going to go through every single one of them. As you know, I've noticed I have skipped. There are two more, though, I would like to show you. There's one over here, this area over here. The idea behind this is that I want to mill off the top of this, but every single time I go down, I want to increase the length of my tool path as I'm going down. Notice in top, I want to start off shallow, and as we go down further and further, I want to have wider steps, because that's according to the material that I have over there. Opening up the operation. Okay. Note, first of all, my home position. My home position in this particular case is the center of this area over here. I have it over here at the time, but it's actually the center of this area. The tool path is just this one line. Now, this operation again is very similar to clear offset. First of all, our direction is important. Could we be working to the left of it? And if I were to go into my technology, first of all, we have our clear offset. How far away are we from the edge itself? If I'm not sure, I can just click on clear offset and click on the edge over there, and the value will go in there automatically. We have our step over. And one more important feature, what's the actual diameter of our circle, of our cylinder that we have over here. Note, it does not necessarily mean, because these parts are not necessarily made that the top surface over here is exactly center of the part. And so in order to figure out exactly how far out to go, it needs to know the offset, it needs to know the diameter of the part itself. Showing it over here, you can see that wall over there. Yep, excellent. Let's take a look at the simulation. And when we look at the simulation, it's actually very interesting. You'll note that the top ones are narrower than the ones at the bottom. And this is done automatically. Okay, now one more operation, and then we'll go to questions if there are any. Is this circle over here. Now this is a simple, typical circle that we have over here. The way I want to work on this is that it goes down the middle and then just does a helical action towards the wall itself. So it's constantly working. If I were to open up the operation, you'll see that the geometry is just a circle. You can also see my tool path is going to be just as you see over here. We have our tool, we have our level. In our technology area, we have our minimum and maximum cutting angle as it's working in a spiral around the part itself. Taking a look again at the simulation. You'll note that we have a spiral tool path around the part. Again, you'll see that the tool you'll see that the tool goes down the middle, spiraling its way towards the outside of the part itself. Okay, so basically what we've seen here in the toolbox is that there are many just simple canned options that you don't have to go to profile to do it. You don't have to go to pocket table to do it and go through every single parameter each time. Here, the actual tool path is created by us according to the geometry to pack here and according to the type of operation that you've chosen over here. Okay, thank you very much, everyone. I'd like to open up the floor now for questions if there are. And I'll wait a minute or two until, if there are any questions, for people to write them down. Okay, again, thank you again for joining the webinar. And hopefully we'll see you again in our next webinars. Take care and have a great day, everyone.